We're going to look at modeling harmonic motion functions. So harmonic motion is a form, this is from the textbook, is a form of periodic motion, but there are factors to consider that differentiate the two types. While general periodic motion applications cycle through their periods with no outside interference, harmonic motion requires a restoring force. Examples of harmonic motion include springs, gravitational force, and magnetic force. So a simple harmonic motion is a type of motion described as a simple harmonic motion involves a restoring force, but assumes that the motion will continue forever. Imagine a weighted object hanging on a spring. When that object is not disturbed, we see the object is at rest or in equilibrium. If the object is pulled down and released, the force of the spring pulls the object back toward the equilibrium, and harmonic motion begins. The restoring force is directly proportional to, let me highlight that. The restoring force is directly proportional to the displacement of the object from its equilibrium point when time equals 0 and distance is 0. So simple harmonic motion can be modeled this way. Equation. So D equals A cosine omega t, or D equals A sine omega t. So instead of B, we're doing omega, where the absolute value of A is the amplitude, 2 pi over omega is the period, and omega over 2 pi is the frequency, or the number of cycles per unit of time. So for the given functions, find the maximum displacement of an object, the period or the time required for the vibration, the frequency, and then sketch the graph. So we have 3 of these to look at. So let's start with this first one. And what do we have here? So our maximum displacement is the absolute value of A, so max displacement is the absolute value of A. So in this case, absolute value of 5. So it's 5. The period is going to be 2 pi divided by 3. That's it. The frequency is going to be that 3 over 2 pi, just the reciprocal. Then if we're to graph it, I just wanted to do it with a generic graph, so I'm going to relabel this. So I'm going to graph, I guess, one period of this. So I'm just going to kind of cross those out. And let's go with, so our period is 2 pi over 3. So I'm going to count 1, 2, 3, 4. Call this 2 pi over 3. So then we'd have pi over 3 here, pi over 6, and then halfway between these two would be, so it's pi over 6, 2 pi over 6, 3 pi over 6, which is pi over 2, 4 pi over 6, which is pi over 3. There we go. This goes up to 5, so 1, 2, 3, 4, 5. Maybe I'll just scale this as 2, 4, so this will be 5 here. Okay, so we are going to be starting here, peaking here, here, bottoming out here, and then back up here. That's what the graph's going to look like. We keep going with it. And we would peak here, cross here, bottom out here, come back up. Okay, let's try the next one. Y equals 6 cosine of pi t. So for the first part, the maximum displacement would be the absolute value of 6, which is 6. Then we have the period is 2 pi divided by pi, so it's going to be 2. And then the frequency is going to be omega over 2, so basically pi over 2 pi. So it's 1/2, which is the reciprocal of 2. So we can graph it. Again, I'll cross these out. So if we call this 1, 2, 3, 4, 5, 6, 7, 8. We can get 2 cycles out of this. And I'll go 2, 3, 2, 4, excuse me, 6, -2, -4, -6. Oh, and the last one, I put a -5 on that. I didn't even write anything. Okay, we'll just leave it like that. Okay, so for this is a cosine function, so it's going to start high. It'll cross, go down low, cross, come up again, cross, go down low, cross, and come up again. Okay, there you go. And the next one, we have y equals cosine of pi over 2t. So again, our displacement, so maximum displacement, that's an L there. It's going to be the absolute value of 5, so it's 5. The period is 2 pi over 2. So that would just be 4. And the frequency is going to be pi over 2 pi. So the pi's would divide out. 1/2 over 2. 1/2 times 1 over 2, which is 1/4, which is the reciprocal of 4. So again, I'll cross these out. One, 2, 3, 4, 5, 6, 7, 8. Wait a minute. Back to the last one. The period was 2. Oh, I got the scaled wrong. That's 1/2, then 1, then 3 halves, and then this should be 2. And then we have 5 halves, and then 3, and then this would be 7 halves, and then this would be 4. Okay, sorry about that. Okay, this one, period is 4, and this is a cosine, so I should scale that. 2, 4, 6, we'll call it 5 there. -2, -4, -6, we'll call it 5 there. So we're going to start high, get across, go low, oops, go low there, cross, come high, cross, go low, cross, come high. Comes down like that. There it is. Okay.